Welcome back to my favorite people, and thank you very much for watching this lecture video. In this lecture, we're going to go through oxidation of alcohols. We mentioned this one before, that if you take a carbonyl group and reduce it, you can turn it to alcohol. It depends what you start with. If it's aldehyde and you reduce it, you get a primary alcohol. If it's a ketone and you reduce it, you get a secondary alcohol. Now, and in this case, I'm going to start from alcohol, and I want to turn it to, for example, aldehyde or ketone, or maybe one step more and go to carboxylic acid. But in order to have oxidation, we need one hydrogen attached to the alpha carbon. Which carbon? The carbon that's holding actually the OH group. And this reaction, and we might lose, say, H2, and if we lose H2, this one is going to turn to, for example, ketone or aldehyde. Okay, let's go after it, and I'm going to start with strong oxidizing agent. And the strong oxidizing agent, they try to go extreme and try to oxidize it to the technically to the end. One of this strong oxidizing agent is going to be the chromic acid. If you take CrO3 in acidic solution, for example, exposed to like a hydronium ion in acetone or sulfuric acid and presence of water, or we can say diluted solution of sulfuric acid plus sodium dichromate, we get this compound. We get chromium attached to oxygen, two oxygen through double bonds, and then we will have oxygen attached to hydrogen. And here, another oxygen attached to hydrogens. And the chromium here, it has a high oxidation number. That means is short of electron, and this is going to happen. It will pull electrons from oxygen, and in order to actually replace the missing electron, oxygen very soon, it will pull electron from hydrogen, and hydrogen is going to have a high positive charge. And so this is going to be our acid, and we call it chromic acid, or sometimes Jones reagent. It's not friendly for environment, and because at the end you need to handle the waste properly. So like as a chemist, honestly, we don't like to use this reagent a lot. Okay, now the Jones reagent, or the chromic acid, it will take a primary alcohol, and it will turn it to carboxylic acid. It means OH, okay, OH that attached to a primary carbon, and that OH is gonna turn to, okay, double bond between carbon and oxygen. Also, we will get this one, OH, and that's going to be the carboxylic group. Okay, and if is a secondary alcohol, let's say we have a carbon that attached to two carbons, and there is an OH here. In this case, we have only one hydrogen. Okay, because I have only one hydrogen, oxidation is going to run through only one step, and O between two brackets means oxidation. Okay, so the oxidation is going to happen only, it's going to move forward only in one step, and we will get such a product. Just simply remove hydrogen from the system, and you will get such a product. This one is going to give us a ketone. So secondary alcohol, it will turn to ketone, and primary alcohol, first it will turn to aldehyde, but it's not going to stop there. At the end, it will turn to carboxylic acid. So this is going to be the final product for it. And now, how about the tertiary alcohol? Tertiary alcohol will not go through any chemical reaction. And what's the reason behind it? If you look to, for example, the primary alcohol, it has two hydrogens attached to that carbon. While the tertiary alcohol, this is going to be the tertiary alcohol. Tertiary alcohol is attached to, it has a carbon that attaches three carbons, and then you will have OH there. Okay, so there is no alpha hydrogen, no hydrogen attached to the alpha carbon. And so here, this carbon has no hydrogen. And because it has no hydrogen, it will not go through oxidation. This one will not happen. So from now, anytime you see a tertiary alcohol will not go through oxidation. Stay as it is. Okay, now what do I have here? I have a ketone, and this ketone, it doesn't have any alpha hydrogen attached to it. But here we have a primary carbon. That primary carbon, it has two hydrogens attached to it. So what will happen? The primary alcohol is going to turn to carboxylic acid. So we will have this. We will have a carbon, this carbon. That carbon is going to turn to a carboxylic acid. And so as you see, we have a double bond with oxygen and also OH attached to that carbon. And this, again, this is going to be technically this group, COOH. So primary alcohol turned to carboxylic acid. Okay. Another example, in this case, we have a secondary alcohol. This one is a primary alcohol, and this one is aldehyde. And we are trying to treat them with a chromic acid. Okay, if we treat them with a chromic acid, let's say it's going to be H2O, or forgive me, I can say HCrO4, or we can say, maybe I should draw actually the structure is going to be better. Okay, so we have chromium attached to two oxygens, and here we have this one. Okay, primary, it will turn to primary alcohol, it will turn to COOH. Aldehyde, this is aldehyde. Aldehyde, because it has alpha hydrogen attached to it, it will again turn to COOH. And a ketone, this is going to be a ketone. Ketone has no alpha hydrogen, and because it doesn't have the alpha carbon, alpha hydrogen, so we say no reaction. Okay, if it's a ketone. But how about the secondary alcohol? Secondary alcohol, this is going to be a secondary alcohol. It will turn to ketone, and it will give us such a product. Okay, so final product in this case, okay, I get, let's say, 3, 4, 5, 6, 7. I need to do a better job. Okay, 2, 3, 4, 5, 6, 7, 8. Okay, and this group is going to turn to carboxylic acid. So the aldehyde turned to carboxylic acid. And then here we have a methyl is a primary alcohol. That primary alcohol again is going to turn to carboxylic acid. So we got two carboxylic acid, and the one like this one is a secondary alcohol. Secondary alcohol is going to simply turn to a ketone, and it will stay there. So those are going to be the final product of the reaction. Okay, and we have, I said, we have a couple of oxidizing agent, and another one, it will be the potassium permanganate is a harsh oxidizing agent. It will take the primary, it will turn it to carboxylic acid, and secondary, it will turn it to ketone, and tertiary, no reaction. Okay, and so I'm going to assign the alcohol. This one is primary, this one is secondary, and that's a tertiary alcohol. The tertiary stay as it is. As you see, I did not change position or composition of that substituent. Okay, it's a tertiary, stay as it is. Now, how about the primary? Primary, it will turn to carboxylic group. So this one, I'm going to say I will have carboxylic group here. And the secondary, it will turn to a ketone. A ketone. So double bond here. Okay, this one will be ketone. And that's going to be the final product. Okay, again, this is a strong oxidizing agent. In order to run the reaction, you need to have a high temperature and also a basic solution. And whenever the reaction is done, at the end, you will treat it with acidic solution, then to technically protonate any negative charge there. Okay, another one is going to be a predynium chlorochromate, or PCC. This is a mild oxidizing agent, and it means that the primary, it will turn to aldehyde, and secondary, it will turn to ketone, and the tertiary will not do any chemical reaction. So you will simply say no reaction. Okay, but your final product will be either aldehyde or ketone. It depends on the starting point. And here we have a tertiary alcohol, and this one is a primary alcohol. Tertiary alcohol stays as it is. Nothing will happen to it, but the primary alcohol, it will turn to aldehyde. Okay, so the primary alcohol is going to turn to aldehyde. As you see, we do have one more hydrogen attached to the alpha carbon, but the oxidation is not going to move forward. It will stop there. It will give you aldehyde. Another mild oxidizing agent, it will be a sodium hypochlorite. And sodium hypochlorite depends on the situation. It can be mild or harsh oxidizing agent. And one mild condition is when you are using acetic acid plus the sodium hypochlorite. And so what will happen here? The primary, it will turn to aldehyde, and secondary, it will turn to ketone. And in this case, because we have a primary, and this one is going to turn to aldehyde. Going to put this one here, and we will have hydrogen there. And this is going to be our final product. Now, what will happen if we, kind of like, if we push the reaction? How? By using a catalyst like, TIMPO. TIMPO is a radical. It's going to speed the reaction, and the reaction will go further, okay? And in that case, the primary alcohol, it will turn to carboxylic group, but the secondary it will turn to ketone. And again, tertiary will nothing happen to it. So in this case, we will have COOH, and we got carboxylic group. And compare the first one versus the second. First one, because it was mild condition, we got aldehyde, while the second, we got carboxylic acid. Okay. Now, what if it's a secondary alcohol? It's secondary alcohol, regardless of the situation, and just max, it can give you a ketone. So that's gonna be the final product. It will be ketone. This is a secondary alcohol, and we got ketone. Okay, another mild oxidizing agent, it will be this Martin oxidizing agent. And this one, and as you see, the structure of the reagent is a bit complicated. OAC stand for acetate. It's a conjugate base of the acetic acid. And what's the role of this compound? This one is going to be a base. Is technically, it will take hydrogen out of the system. And in this case, the primary alcohol, it will turn to aldehyde, and the secondary, it will turn to ketone. So I'm going to get a ketone here. This one, it will be ketone. And primary, it will turn to aldehyde. Okay. And another reagent, it will be here. Let's forgive me. We have one more example here, and this example does have double bond and also OH, and the reagent or oxidizing agent is not going to touch the double bond. The only thing will happen, the primary alcohol, it will turn to aldehyde. So again, we get aldehyde, but the double bond and then will stay completely untouched. Okay, the Swear oxidizing agent, and this one is another mild oxidizing agent. And what it will do, it will take the primary alcohol, it will turn it to aldehyde, and secondary to ketone, and tertiary stay as it is. This is a tertiary alcohol, while that one is a primary alcohol. So I expect to see here a double bond and then hydrogen, and the tertiary will nothing happen to it. Okay, so this is going to be aldehyde, or maybe I should write there. So this one, it will be C attached to O and hydrogen there, or aldehyde. How about the rest of the product? Okay, the oxylyl chloride, this one, and it's going to give us CO and CO2 plus Cl and dimethyl sulfoxide. This one at the end, it will turn to dimethyl sulfide. And how about the base? The base, this one is going to gain, technically, is going to gain H. It will take H from the system. It will turn to HB plus 1. Okay. And again, this is oxidizing agent. I don't want you to, know the exact mechanism of it. If you practice, that's very good. But if you don't know it, again, I'm not going to ask you, during the exam. And many, many faculties will not ask you such a question. And when I say a question, about the detail of the mechanism. Okay. Another mild reagent, it will be manganese dioxide. Manganese dioxide, and it will go only after allylic alcohol. And what's the allylic alcohol? We have a carbon. Let's start, for example, from here. 1, 2, 3. On the third carbon, the one that is conjugate with the double bond, and on the third carbon, we have OH. That OH, technically, you can say is an allylic alcohol because it's a conjugate with a double bond. And what's going to happen to it, this one, it will turn to aldehyde. So we will get hydrogen. And then here, double bond with oxygen. But that one stay as it is. Nothing will happen to it. And how about PCC? PCC, as I said it before, is a mild reagent, mild oxidizing agent. It will take this one and it will turn it to aldehyde, similar to manganese dioxide. So until now, it's going to be the same, but the problem it will be here. This one, because it's a primary alcohol, that's a primary alcohol. The primary alcohol, it will turn to aldehyde. So PCC has no selectivity, while MnO2 or manganese dioxide, it will only go after allylic alcohol. Be careful about it. And that's going to be end of this lecture, and thank you very much.